This is lesson 84, and this is going to be the probability of independent events. I'm going to say it's on 170 and 171, but it's actually going to be on a worksheet. Independent events are events that happen that do not affect each other. If I flip a coin and then I roll a dice or a individual die or a pair of dice, they don't affect each other. And I'll show you the difference when, especially on an example like the cooler, and we'll see those on the next lesson in lesson 85. What do you do when they do affect each other? And we're going to actually start with this number 2. It's kind of lengthy, but I think it'll make sense as we go through it. A cooler contains 13 bottles of sports drink. How many drinks do we have total? 5 lemon lime, 4 orange, and 4 fruit punch. You randomly grab a bottle, then you're going to put it back in the cooler, mix them up, and select another one. The first time you get a lemon lime, and the second time you get a fruit punch. Now, the reason this is considered independent is because you didn't keep the drink out, and it didn't affect what was left in the cooler because you had one less drink in there. And we'll see those, like I said, in lesson 85. So, the first thing you want to do is set up a fraction. And the bottom number is going to be the number that you have total. And then the top number is going to be the number of items that meet the condition we're talking about. So I'm just going to put condition. So in this case, we had 13 drinks. And we want to draw a lemon lime drink. And the lemon lime drink, there were 5 of them. So of the 13 that are in the cooler, 5 of them are lemon lime. Times, now the reason these are times is because we are doing and situations, and that's all we're doing. So everything's going to be flip a coin and roll a die. It's going to be spin a spinner and flip a coin. You're going to be doing and situations, which is multiplication. We usually don't do the or situations, which becomes addition later on, but we usually don't do those in geometry. We usually save those for Algebra 2 or college algebra. So this is our first time, and then the second. Now, if you only drew one out, you'd be through with it. So, but every one of these, we're going to be drawing one, doing one or two or more things. So the second time, we put it back, so there's still 13 drinks in the cooler, and we want the second one to be a fruit punch, and there were 4 fruit punch. And then when we multiply those together, we get 20 over 169, which is in lowest terms. It won't reduce, and that's our answer. A lot of times they will change them to decimals, and if you divide this, and I'm thinking on your classwork, it's going to give this answer, but it's also going to give the decimal, and I believe they're going to round to, most cases it looks like 2 or 3 decimal places. So we've got 20 divided by 169, and I got 0.11, and then we're going to do 3 in this one. That's what the answer does on the answer key. So the 3 would make the 8 stay the same. You could do the 1, 2 if you let the 8 round. You just have to watch in your multiple choice answers. Now it's going to give both of them, so you're going to have to be careful, and depending on what calculator you're using, if it's going to give this fraction, and we'll talk a little bit about that if we get to one that will reduce in just a minute. Okay, let's look at this one. It says you flip a coin. Okay, and then we're going to roll a die. So I'm going to do one event and a second event. So first, we want to flip a coin, and we want it to land tails up. Well, how many choices do you have on a coin? You have 2, heads or tails. And our success, or our condition that we want, is tails up, and only one of those is tails. It's either going to be 1 tails up or 1 heads up. Now let's look at our die. We have 6 sides, and we want it to be an odd number. So let's look at what's on a dice, on one single die. 1, 2, 3, 4, 5, 6. Our odd numbers are 1, 3, and 5. So of the 6 numbers here, 3 of them are odd. Now, you can multiply, and you get 3/12. And then you can reduce here, and you get 1/4. And that's exactly 0.25 when you change that one to a decimal. It's not approximate. You could also have reduced over here. You could have reduced the 3 and the 6. It would have made the arithmetic a little bit quicker. So you do have to be careful as you're doing the fraction and the decimal. Okay, let's do number 5 here. It says a basket contains 6 apples and 6 peaches. Oops, sorry. Here we go. 3 times you randomly select a piece of fruit. So 1 fraction, 2 fractions, 3 fractions this time. 3 times we're going to draw a piece of fruit. We're going to put it back. You keep it out. That is going to be what we call dependent. It's going to affect what you keep out is going to make a difference in the second situation. So 3 times you select a piece of fruit, return it to the basket, and then mix the fruit up. So the first time I'm going to choose how many pieces of fruit are in the baskets, 12. And I want all 3 times I want it to be an apple. So there are 6 apples in the basket. So of the 12, I draw one out, and 6 of those meet the condition. So half of the fruit are apples. And so we put it back in. And then the next time, there's still 12 pieces of fruit in the basket because I put this one back. And then I'll look at that situation. I'll say, I reached in, I got an apple. So there's 6 of the 12. 6 of the total are apples. I'm going to put it back in and do it one more time. And 6 of the 12 are apples. Now, it is much easier to reduce these as you go than trying to do those big numbers, because I just made each one of them 1/2. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And as a decimal, that's exactly 0.125. Okay, number 9. There are 8 nickels and 6 dimes in your pocket. 3 times you randomly pick a coin out of your pocket, return it to your pocket, and then mix up the change. And again, all of this is based on putting it back in. The first time the coin, you want it to be a nickel. Put it back in. Second time, it's going to be a dime. And the third time, it's going to be a nickel. Now, let's see what we have in our total in our bag. We're going to draw 3 times. And we have 8 and 6. We have 14 coins. So we take it out, look at it, put it back in. So there's 14, 14, 14. We're going to do it 3 times. Now, what are our conditions? The first one is a nickel. Now, how many of these 14 are nickels? 8 of them. We put it back in our pocket. This time we want a dime. There's 6 that are dimes. Put it back in. And then the third time we want a nickel. And then the nickels are 8. Now, they don't reduce as easy, but they still reduce. So 2 goes 4 and 7. 2 goes 3 and 7. And 2 goes 4 and 7. Now, instead of multiplying them as fractions, I'm going to just do, since I've done my reducing, I'm going to do 4 times 3 times 4 on top, and I get 48. And I'm going to do 7 times 7 times 7 on the bottom. And an easy way to do that is just do 7 raised to the third. And I got 343. Now, I don't figure that one's going to come out even. So we'll do 48 divided by 343. And we get about, they probably rounded it to 2 decimal places. Let me see what they did on the classwork. They rounded it to the 2, which is going to be the 1, 3. Oh, let me let you see that. The 1, 3, 9. The 9 is going to make the 13 go to a 14, so that's about 0.14. And you'll want to look at your answers. I don't think they'll be that tricky, but be careful if they're similar, you want to make sure they match up. So you'll just have to be careful. You can go directly to the decimal, so just be careful as you multiply.